Okay, so today we're going to start a new unit, and our first lesson is going to be about negative numbers and the addition and subtraction of integers. So just to start off, suppose I want to buy a book, and the book actually costs $15, but I only have $10. What can I do? Well, I can borrow money. So I could borrow, there we go, $5 from my mom or a friend or whatever that may be. And if I represent this in an equation, then I have $10, but I'm spending $15, which means that I have minus $5. This minus $5 is just saying that you owe $5 or you have $5 of debt. In each of the following next examples, we want to find a way to numerically represent them. So in A, the temperature outside is 10 degrees Celsius below zero. So we would write this as minus 10 degrees Celsius. B, the water level is 4 meters below sea level. So we would write this as minus 4 meters. And a loss of $200, and we would just write minus 200. Oh, I forgot my dollar sign. There we go. Alright, so integers. Integers are very similar to whole numbers, except for they include negatives. So an integer can be plus or minus 1, plus or minus 2, plus or minus 10, plus or minus 100, a million, 1,000. There's lots of examples. And we like to use number lines to actually arrange numbers on there. So for example, if you were asked to arrange -5 and 3 on the number line, then you would say, oh, okay, well the number -5 is over here, the number 3 is over there. The thing with number lines is that we always have a 0 in the middle here, and then this side is always going to be positive numbers, and this side will always be our negative numbers. Alright, so now we actually want to be able to compare them, and we really like these two symbols. Now, the first symbol, as I read left to right, I get to the little tiny point of it first, and we call this our less than symbol. And the other symbol, as I read left to right, notice that I get to the big part of the symbol, and this is our greater than symbol. So if I'm comparing 10 and 6, I would say that 10 is greater than 6. In B, if I was looking at -5 and 3, -5 is less than 3. And now for C, it says -2 and -5. Now if you're not sure, you can look at the number line, and you could go up here and say, well, -2 is right here, -5 is over here. Okay, well, -2 is in fact greater than -5. They're both negative, but one of the numbers is actually bigger than the other. Alright, let's put some things in some charts. So we have an original temperature, we have the way our temperature changes, we have a new temperature, and we can represent this mathematically. And in fact, what I'm going to do is I'm going to put in a number line here. You guys should put one in here too. So I'm going to start at 0 here, 1, 2, 3, 4. I can stop there. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, -14, -15. I think that's as far as we need to go. So the original temperature is 13 degrees Celsius, and the change says it decreases by 9 degrees Celsius. So mathematically, we started at 13, we're decreasing by 9, our total is 4 degrees Celsius, so our new temperature is 4 degrees Celsius. In the second one, it says we start at 2 degrees Celsius, and it decreases by 5 degrees Celsius. So we have 2 minus 5, and if you want to do this in your number line, we start at 2, and we're going back 1, 2, 3, 4, 5, so our answer is -3 degrees Celsius. Okay, new temperature is -3 degrees Celsius. We start off at -2 and we increase by 3 degrees Celsius. So mathematically we start at -2, we increase, which is why we have a plus there, by 3. And if you don't see it right away, you're welcome to go up to the number line and say, okay, well I started at -2, which is right there. I went up 1, 2, 3, so I'm at 1 degree Celsius. You want to be able to get away from the number line so that when you get to the test, it comes quicker. But to start off with, it's okay. So the next one is, the original temperature is -9 degrees Celsius, and it decreases by 3 degrees Celsius. So we don't have to put the Celsius in until the end if you don't want to. Okay, so we start off at -9, which is right here, and I'm decreasing at 1, 2, 3, and so I get to -12 degrees Celsius. Okay, so a few examples. Let's try and do these without the chart. So we start off with 3 plus -2, and we can rewrite this as 3 minus 2. A plus and a minus is just a minus, and this in fact will equal 1. Now the next one is 4 minus -2. And the minuses are just direction changes. So if you started in a minus direction, but then we're changing directions again, all of a sudden we're going in a plus direction. So we can rewrite this as 4 plus 2, which is just 6. For C, we have -5 minus 6. So we go back 5, and then we go back 6 more. So if I go back 5 and then I go back 6 more, I've gone back 11. And you can try and think about this as steps if you want to. So if you take 5 steps backwards and then you take another 6 steps backwards, how many steps backwards have you taken? Well, -11 steps. We can rewrite D. So D says -7 plus -9. A plus minus is still a minus. Okay, so that this minus symbol is just talking about direction, and it's telling us that we're going into the negative direction. So we can write this as -7 minus 9. Again, if you want to think about it as steps, we're going to go back 7 steps, and then we're going to go back another 9 steps, so in total we get -16. In general, the rule is if we have a plus minus or a minus plus, this is just going to be minus. If you have a minus minus, the change of direction has happened twice. So in fact, we get a plus. Now, a lot of my students have said to me that they remember this by just connecting those together and they see the plus. However you want to remember it is fine. If you remember that it's a direction change twice and it becomes positive, then that's fine. If you just connect the lines there and you see the plus, that works as well. Okay, 2 more examples. So true or false. So to add 2 negative integers. Okay, so when we're adding 2 negative integers, we find the sum of their numerical value and take the negative sign for the answer. So if you think about that, my example, if I have -3 minus 3, or let's change it to -3 minus 2. Okay, they both have negatives. So if I was, for example, to add 3 plus 2, I get 5. And because they're both negative, we can write this as -5. Now, if you wanted to think about it as steps, if you went back 3 steps and then you went back 2 more steps, you would have gone back 5 steps. And so both ways you get the answer of -5. This way, it's just a little quicker, and we're pretty good with addition of positive integers or whole numbers. Okay, the second one. Given that a positive, I should write, this is true. Given that a positive integer is numerically larger than a negative integer, so we'll read that again. Given that a positive integer is numerically larger than a negative integer, to add these 2 integers together, we find the difference between their numerical values and take the positive sign. So basically what I'm saying is if you have something like, for example, minus 2 plus 3. Okay, so if I go back 3 steps and then back 2 steps and then forward 3 steps, in fact I'm going to get to minus 1 steps. If you wanted to look at it as 3 minus 2, because we're pretty good at looking at a 3 minus a 2, in both of these we get the answer as 1. So the order of addition and subtraction doesn't matter as long as their sign stays with them. So notice that the negative sign has stayed with the negative 2. And in fact, the positive sign has stayed with the positive 3. We have the invisible plus sign there. So this is also true.